I'm Timo Salm. I'm a pre-sales specialist for developer experience at VMware/Broadcom, responsible for our internal developer platform products on Kubernetes and also the commercial Spring products because I have a software development background and collaborating a lot with our Spring team and feedback regarding, for example, currently a lot about Spring AI, but also all the other technologies that are interesting for our customers. The agenda for today, so first I will give a short introduction what serverless is, because we want to go serverless. For that we have to understand it and also the value of serverless, because otherwise we don't have to use any technology if we are not aware of the value. Then I will show how a standard Spring application, so really basic Hello World example, performs on a serverless platform. And based on that, we will see what we can maybe improve, and then how those technologies mentioned here will help us to do that. If we talk about serverless, serverless doesn't mean that there are no servers. The thing is, you just don't have to care about them. And you can group serverless into two groups. So there's one called backend as a service. And instead of managing your own servers and all the stacks that you need until the layer where you run your software, you actually replace them with off-the-shelf services or even maybe the software. An example is instead of managing your own authorization server, that you use something like Auth0 or Okta. So you don't have to care about the stuff for sure. It's also like you lose a little bit control, but at the end you can focus on the stuff that's really relevant for your business. The other one is function as a service. It's a new way of building applications as smaller functions and also deploying them. Examples are, you may have heard of AWS Lambda, for example, is a typical runtime for function as a service. So you deploy small functions. It's easier to deploy them. You don't have to package them in containers, etc. And then they run. They have auto-scaling, etc. This is how you usually use it. And it's also always, if you think about those technologies that improve your runtime efficiency, you should always think about what's the value of that for me. Is it like, okay, I have a lot of instances, they consume memory, or is it just like, okay, I need faster startup times because I have unpredictable demand and I have to handle it? That's always important. The key of both is at the end that, instead of managing servers, your hosts, etc., with both of them, you really focus on the business value. I have an application, that's my business value, and I run it somewhere. I want to run it somewhere. The why? Shorter lead time, which means that actually because of this reduced complexity regarding the packaging and running application, you are faster and can provision stuff faster. The flexibility in scaling, as already mentioned, especially if we talk about examples like AWS Lambda, you have a huge flexibility in how much you can scale, which is also something you have to control in a way, otherwise it will be really expensive. The reduced labor costs for sure. If you don't have the people that manage all the hosts, etc., on the servers, you have to pay for the service from someone else, but actually you don't have to pay those people that do it, and also the resource costs if you're using, for example, things like auto-scaling or even scale to zero. Last but not least, all of that is a reduced risk. But the thing is, there are a lot of drawbacks. So that's just like some on the slide. Actually, one of them I already mentioned is unpredictable costs, especially if you're running them on a cloud provider, because there are unlimited resources, more or less, which means that it can be really expensive. Another problem we will actually try to mitigate is that spinning up machines takes some time. So if you have scale to zero, standard Spring application, depending on the size of your application, it can take several seconds until the application is ready to serve traffic. And at the end, within 10 seconds, most of the clients already time out, which means that they will fail. And this is also something you have either you to handle in your application, or you need ways to avoid that by, for example, pre-provisioning stuff or by making applications as fast as so that there are no timeouts in most of the cases. There's more like vendor lock-in if you're, for example, on AWS Lambda, because it's like that's not a standard how the applications are packaged. And nowadays also support containers, but before, or if you run it in the AWS format, I would say that's a vendor login, for example. And yeah, one thing I also mentioned is the loss of control for sure. If on AWS they have a problem, or also in Azure, you cannot do anything. You just have to wait until it's back. Let's now start and try out our first application. As that, it's a really basic one. It's just a Hello World application. You can see it here. We're using, in this case, Java 23, just the latest and greatest. Also from Spring version, we use 3.3 because actually the latest versions of Spring Boot and Spring Framework, they added support for several of those technologies we're using here, like, for example, Project CraC and CDS, and therefore I'm using the latest versions here. So that's really important to get it working. All the code is available in a GitHub repository. You will see a QR code later that you can scan to get the link. And as said, the rest, there's some additional stuff happening here because of the fact that I want to enable, for example, CraC here based on specific profiles, or you can see here that I'm setting some environment variables for CDS. So yeah, if you want to have a look, you can have it later. At the end, what I'm doing here now for this simple run is just like, without any additional parameters, I package the application and then we'll run it on a serverless runtime. The serverless runtime I chose here for this example is Knative. It's an open source solution running on Kubernetes. So if you have a need for serverless runtime, but you are in data centers, that's one of the solutions available. It provides auto-scaling. It provides a high abstraction with auto-ingress creation, for example, for your applications. So a really nice solution that's also there for several years. Building your container images with Spring Boot, for sure you could create a Docker file. That's something for some of the examples I also did. For example, for Project CraC before, because there is no support from so-called build packs available. But since Spring Boot 2.3, we have build pack support in Spring, which means that those build packs, they detect which type of application you have, that it's a Maven or a Gradle. They detect the Java version or everything you need to actually run your application in a container. And then they will run based on a command and build a container image and provide everything it needs to run your application. So that's out of the box available in Spring. And the commands are different. So for Gradle, it's build image, for example. And with that, then you have your container image, can push it to a registry and use it. I have also, just for information, if you try it out, all the different steps available here. So you can see boot build image with Gradle without anything additional, Docker file, etc. You then will have your container image. You can push it, but all the container images are also available in the Git repository. Okay, so let's now try our application. So we'll go to the terminal here. You can already see the command. So it's kn is the knative CLI. I could also just create, because it's Kubernetes native, a YAML file with all the configurations. But here, that's the easiest way to just show it to you. The name of the Knative service I would like to have. And then here I have my image, which is available on GitHub. And if I run that, what Knative will do, nothing. Sorry, I have to log into my Kubernetes cluster again. Okay, now if I run it, what it will do is it will apply this custom resource called Knative service, which actually creates a deployment, which creates an ingress that is configured, and a service, so everything I need to run a simple application, which is exposed externally automatically. With Knative, as I mentioned, I get this auto-scaling functionalities to scale to 0 if I don't configure it to thousands of containers if I'd like to, but that's also something you can configure. It takes a few seconds because it's also checking whether my application is reachable. And instead for that, it takes some time until everything is configured also from an ingress controller perspective. Now I got back an URL where my application is running. And I can easily just curl it if I'd like to. And should get back a really basic, hello world. And if we now have a closer look at it, so at the pods, because what's relevant for us is how it performs on a serverless runtime. We can see here's our pod, and if we have, for example, a look at the logs of the pod, we at the end should be able to see that even if it's like the most basic example of a Spring application available, or Spring Boot application, we have a startup time of 6.5 seconds, which is a lot. And you can imagine if I have a lot of requests and I have to start my application, or even I have a scale to 0, that my application times out. That's something we can also just validate here. So I run 1,000 commands against this. I have to run it on to the right one, actually. But you can see that it takes a lot of time until Knative is able to serve traffic. And with that, the problem is that not only clients could time out, also like that Knative is going in a like rage mode. So it's spinning up more and more containers because of the fact it thinks that, all the containers that are there, they are not able to handle the traffic. So, okay, let's do the other one with the correct URL here. Well, where is it here? Let's see. Unfortunately, the internet is a little bit slow. But you can see that now they are running, so some of them, but some of them not. And it's like, as said, it takes around, in our case, 6.5 seconds until they are all up, and therefore you can see all those instances that are created just because of the fact that Knative thinks, okay, no one is able to handle my demand, I have to spin up more. And so that's a problem we actually want to mitigate. On the other side, we can also have a look at the memory consumption. You can see around 200 megabyte, which means that if you have a lot of instances, you consume a lot of memory, which could be also a problem regarding the costs and resources. CPU the same. There's also some room for improvement, so that's something we want to maybe mitigate if we really want to have this on-demand, not on-demand provisioning, or on-demand provisioning, and not like having always the same demand where it's like, okay, I run my 5 instances, that's enough. So at the end, how can we unleash the full potential of serverless for our application? Startup time, lower memory consumption, and at the end, this will lead to more cost savings. But one more time, if you don't need it, so if you don't have like this increasing and decreasing demand, scale to 0, for example, if that's not an option for you, I would always think about whether it's worth the effort to get it working with the technologies that are available. And the first technology, nearly all of you have already heard of, is GraalVM native images. It's actually currently heavily pushed in the last few years by Oracle as an open JDK variant, where in addition to all the functionality of the JDK, It also has the capability to build native images, which are at the end really executables that are compiled for a specific operating system. The code to actually get to those native images is ahead of time because you are more or less eliminating all the dynamic behavior you have in your applications. And as you know, Java is a really dynamic language. So that's what it actually is. So compilation of the code ahead of time instead just in time, and then to a native executable. For those that are not aware of just in time and ahead of time, just in time, this is what usually happens in your applications, which means that all the Java files you have, class files, they are going through a compiler. They are compiled into bytecode, put in a jar, and then on the server side or runtime, they will be compiled also for those paths that are actually frequently executed with a just-in-time compilation also into native code. But that's something. Those are all optimizations that are running on the server side, which means that the compilation is a lot faster. But then you consume memory and CPU, and also increase the startup time. So that's the drawback of it. But in the past, it was not that much of a problem. It's like you had one big application. It takes some minutes to start it, but then everything runs, and you have the full throughput and performance. With ahead of time compilation, it's different. It's like you also produce a jar, but then in the ahead of time compilation, everything is already compiled to bytecode to a native executable, and you only run the native executable. The important aspect is also like that there's no JVM involved. There's a so-called substrate VM, which is providing the core functionality that you need to run your application, but actually there's no JVM anymore. So anything you think about optimizations, you think about dynamic features, etc., a JVM has is not available with a GraalVM native image. So the question is, if you have a dynamic application, and most of them are using dynamic features like reflection, etc., how can I run it? And at the end, it's if you know which kind of dynamic functionality you want to execute, for example, based on tests, etc., you can generate so-called native hints. That's just like a summary of all the methods, classes, etc. you are using, and this will help the GraalVM native compiler to put all the classes into this native executable that you need. If you have an application where it's like I really have dynamic stuff, or maybe even on the as an input I have dynamic stuff, and based on that there will be something done with reflection, etc., that's not working at the end. So that's something you have to in mind. If you're using a lot of dynamic features, it's probably or maybe not the best solution for you. But we can actually give it a try, see how it performs. It's also like Spring Boot provides support for it out of the box. You can, like I did before with the build packs, you only in Maven have to provide a flag. Then for Gradle, you have to add only the plugin for GraalVM, so the Gradle plugin, and then you can also build your native image, and you can for sure also do it via the standard build tools, like for example Gradle native compile to build the application. So all the tools you have are part of it already, just by adding this one dependency. If we have a look at it, and as I said, it's also all, you can see all the steps in the Git repository. Let's run our application. So the native image. And in best case now we see some improvements. You can also go here there and see that it's already starting our container. And it's running. So it looked like a little bit faster, but let's wait until it's deployed here. It's still working as expected. And if we now have a look at the logs, we can see that our application started in 400 milliseconds instead of 6.5 seconds. So it's a really huge improvement due to the fact that, as I said, it's like everything is ahead of time compiled. It's put in a native image. There's no JVM involved, no just-in-time compilation, etc. So everything is optimized and works really well, as I said, without those limitations. If we have a look, and that's also like if I run my hey command again here and with 1,000 requests, we should also see that it's if the URL is the right one, but I think it is. It's a lot faster now, and my traffic can be served actually. Sorry. Yeah, it doesn't work out that well, I think, because of the internet connection, because I'm sending 1,000 requests from my local laptop to the internet. And therefore, as you can see, we run into those problems. Let's see, but I'm still on the internet, okay. If not working, I have to change to my mobile internet here. Sorry. So at the end, what I also want to show you with this GraalVM native images, okay, here it looks better, is that let's spin up one. Okay, there's one, and you could also see. So there was none how fast it was now, and I can also. It will probably take a few seconds. If I have a look at the metrics, I can also see that the memory is dramatically reduced on the. So the CPU core not in this case. That's because there was some handling of the request, but it will also go down after a few seconds, as you can see. So the CPU is a little bit reduced, but the memory is dramatically reduced because before we had around 200 maybe bytes. So it's like that's also something not only reduces the startup time, it also reduces the memory consumption a little bit, the CPU consumption. Which is a great achievement, especially if you're running a lot of instances in parallel, so horizontally scaled, because with that you can really save money with 4 times less memory, and then the startup time at the end helps you to really be able to scaling down to 0 and don't have the pre-provisioning stuff if you don't need it. Okay. Those are the benefits, but actually they are trade-offs. And for the first one is the developer productivity. Because it's not only about the tools, the problem is if you compile your application ahead of time and as a native image, it takes a lot longer and it consumes a lot of memory. So the compilation. And as an example here, I have it. This is the application without anything. You can see the container image was built in 40 seconds for my application. So building the application, putting it in a container. If we switch to our GraalVM build, you can see that it took 3 minutes and 30 seconds. So it's like a lot longer, and that's the most basic example. So if you have more complex application, it can take a lot of time. And also from a memory consumption perspective, if we have a look, we can see that it took around 3.5 gigabyte of memory for this basic example. So for developer productivity, really not the best. That's something you always have to keep in mind. It's not just like that you get those benefits. There's also usually some drawbacks, and here it's a massive drawback regarding the developer productivity. If you still see the benefit for GraalVM for your applications, and there are a lot, then the recommendation is to delegate the building of the native image to a CI/CD pipeline, and on developer notebook also only compile your application ahead of time, so that you can check whether everything regarding the compilation works, and then only have the native image really built on the CI/CD pipeline. That's the recommendation here. I said dynamic features is also a problem. You have to provide to everything you're using those hints if it's dynamic, which can also not be that easy if you have a big application. In best case, all the libraries you're using, they already provide that. If that's not the case, there's also a Git repository where the community provides hints for libraries that are not yet providing those. So just have a look whether all your libraries also support that. And then the last thing, which is also regarding Spring, or for Spring, a bigger constraint is that also the JAWS path and the bean conditions are fixed at build time. Also stuff like Java agents, etc., are a problem. So there's some trade-offs, but if you really have those applications that get a lot of benefit out of this autoscaling, fast autoscaling, and memory reduction, it could be a try. But yeah, with that, there's a question: are there better or other solutions available? And actually, they are. Okay, regarding the time, I will first show how with Spring Boot it's possible to provide those hints, because usually it's like you have to put them in files. And in the meta.in folder for GraalVM to pick them up, but Spring tries to support it as much as possible. So all those standard resources, etc., from Spring, like application properties, etc., they are automatically already handled for you. It's just like if you have other resources like images, etc., you have to provide hints for them. And that's something you can do via application code if you like to. You still can use the text files to do that. And here's an example for that. With most of the common ones, you can see for reflection, where the classes are and which methods you are using. Also here then for resources that are used or serialization. So for all of them, there are methods available. You can register that, and with that, Spring will then create those hint files for you. Actually, Next one I want to talk about is Project CraC. So that's something most of you haven't heard of it. At the end, the idea of Project CraC is that, or the benefit is it's still using the JVM, so there's no change. The only thing it does is more or less you warm up your application on the JVM. It takes a snapshot of this warmed up JVM and restores them. There are for sure several considerations involved. The first thing is, where do you take the snapshot? And the problem with the snapshot is that it's really a snapshot from the full memory. It includes all the credentials that you have, which means that in best case, you are not, or let's, easy example, I see often at customers, they have production air-gapped environments. No one is able to access them. How do you want to take a snapshot with the valid credentials, etc., of the JVM outside of this environment? Not possible. So therefore, there are two ways to do that. You can create a snapshot within your CI/CD pipeline. If you're not afraid of leaking any credentials you have, for example, databases, etc., the better approach would be if you do it at runtime on your target environment. That's also where I have the samples for. So, which means you start up the application the first time. If there is no such snapshot available on a persistent volume, for example, the application will create one, save it to this persistent volume, and then other instances will pick it up, and then they have the improvement in the startup time. So that's the idea of that. Spring also supports it nowadays. The thing with Project CraC is also from a Spring team, they don't think that it will be that famous or popular in the future because of those actually, I will show some trade-offs. And the first one with this fully warmed up Java process, that's maybe something you can get to work, but actually getting the snapshot without credentials, I think that's a problem. On the other side, it's also like one of the trade-offs is that the Linux requires specific capabilities which are not part of all the common versions you are using currently. So, like for example, I used the standard image on AWS for my Kubernetes cluster. It didn't work. Then I checked it. Okay, those capabilities were not available, so I switched to Ubuntu. That's also something you have to be aware of. And last but not least, is it's also like that if you do the snapshot, you have to actually stop all the external connections that you have, which means to any database, etc., and start it again, which means that for some cases, you also have to implement that yourself. So that's nothing standard or out of the box available. With that, there are a lot of trade-offs involved, but it's still running on the JVM, which is a big benefit. And if we test it on our cluster, CraC. You can see it's starting. Okay, running. If I have the logs, I can see I have a startup time of 244 milliseconds. So it's similar, it's not the same, so it's a little bit worse than with GraalVM native images, but a huge improvement in startup time with something that's still running on the JVM, because actually it starts completely warmed up, fully warmed up. That's also something for those that were this, having the peak performance is really important at the beginning. That could be also a solution, because that's something that really ensures that works really well. The thing it doesn't optimize, because of the fact that it's still running on the JVM, etc., is the memory is more or less the same. So it's like no memory improvements, but actually regarding the startup time, we have a huge improvement with Project CraC. The question is there something more where I can just use it without all the drawbacks? And actually there is one that's really easy to use. This is already used by your application, which is class data sharing. At the end, what class data sharing is, it's already part of the JVM. It's there for years. So I think Java 5 or something like that. So it's really major. It's used by the JDK already. And what it does is usually you have this class loading. mechanism that consumes time, memory, etc. And with Glass data sharing, what's done is you create a run of your application that actually identifies all those classes that will be used. Those will be then saved in a specific format that can be directly mapped in the memory of your application, which means that the startup time gets faster. Not that dramatically than with GraalVM, but 2 to 4 times faster than without an application. And you only have a really few drawbacks. So it's like okay, I have to run this this test run on the same JVM than actually, for example, the real application. So if you change that, it still works, but you don't get the benefits because it's like it has to be the same. Yeah, the rest is really easy to use, and it's also like supported by Spring Boot 3.3, so the latest version. And there you can just set one flag if you do, for example, the container building with build packs, and you have the benefits. So it's really great solution to get some benefits actually. Here's another list of how that actually works. But in the end, it's really this what I described. Instead of loading the classes by the class loader, etc., it will be done in this training run and then directly mapped in the memory. If we have a look at it, just the same CDS. And as said, all the details are actually in my code. Can also show them in a second, but so it's starting. Okay. Okay, here, so without anything, it starts instead of 6.5 in 5 seconds, not that much of an improvement. But at the end, there is more because so here the trade-offs I already mentioned. One more is, but that's resolved with the latest Spring Boot version, that you're not able to use Uber jars, so those that are usually generated if you package your application, but there are tools available to unpack that. I said there's more, and there is a Project Layden, which is also there for a few years. And actually, Project Layden, its goal is to improve the startup and runtime performance of Java applications. And what it will use for that, so it's already available as early access builds, you can give it a try, is that it uses CDS, class data sharing, as a new called ahead of time cache. It's using ahead of time compilation plus the CDS mechanisms to actually get to those benefits. As I said, it's still in preview, not available, but what also the Spring team is seeing is like 2 to 4 times improvements compared to the standard one. So also I would say so a little bit more that you saw now out of the box just with a JDK. So that's an official JDK project. So yeah, at the end, as a summary, you have currently 3 options. I would say GraalVM is the one that's available that provides the most outcomes. Actually, the thing with GraalVM is, as I said, developer productivity is lacking. And if you have a really dynamic application, that's also probably not the best choice, but something you could try out. Oracle is heavily working on mitigating things like developer productivity. There's also, they introduced a mode for the GraalVM compiler for development where it's a little bit faster, where they are not making all the optimizations that are doing for the production image. Then there is JVM checkpoint restore. I said also something you could try, but from the Spring team perspective, they don't think it will be that popular in the future because there's those restrictions that are mentioned. where that you have to create those training runs, etc. In best case on the runtime, and also like that it's not an official JDK project, so it's led by Azure. And then we have class data sharing, which is the one you can more or less directly use, try out, get some benefits, and as that with Project Layton, those will be even better. Yeah, and here is the code. So it's all the examples. You can see instructions how to try it out yourself. Also in the code, there are all the commands to actually get it working. And I also have GitHub actions that create the containers on any push. So you can also just consume the container images I have there in the Git repository. Yeah, and that's it for today.